Oh yeah, in this video we are going to continue our studies in solving systems of linear equations using the substitution method. Remember that we use the substitution method when we have a variable in one of the two equations already on its own, or if it's really easy to get that variable on its own. So the instructions say solve using substitution. And what I notice in this first system, we have x equals y minus 5, x minus 3y equals 3, that I have x is equal to y minus 5. So in my mind, I'm thinking x is y minus 5, which means anywhere there's an x, I can replace it with y minus 5. So I have an x down here, and since x is y minus 5, I can replace this value right here with y minus 5. Now let me show you this idea a little bit more concretely. Pretend that this is x, the open space. You have minus 3y equal to 3. We already know that x equals y minus 5. So I will replace x in this empty spot with y minus 5. There you have it. Substitution has been done. Now all we have left to do is to solve the equation for y. So I have y minus 5 minus 3y. I combine the like terms. That's y minus 3y is negative 2y. Minus 5 equal to 3. And again, another public service announcement. If you're having trouble solving any equations, go back to chapter 2 in Algebra 1 content and you will see tons of equations that you can rock. Okay, so negative 2y minus 5 equals 3. I'm going to add 5 to both sides. Very simple equation to solve. Not bad at all. And I'm going to get negative 2y is equal to 8. It's a beautiful thing. Divide by negative 2. Ooh. And we're left with y equals negative 4. Now, one thing to remind you of, just because you got a solution to this equation does not mean you're done. Keep a visual in your head. You're trying to figure out where this line and that line intersect, which occurs at an x and a y value. You have the y value, now time to substitute to find the x value. So it does not matter which equation you plug y into, since they're going to be intersecting at the same point. I picked the first equation because it's easier to plug in and solve for x with. So I'm going to now do x equals y, plugging it in there, which is negative 4 minus 5, which is equal to negative 9. So I get x is equal to negative 9 is our answer there. Now if your teacher wants you to put this in coordinate form with like a point, your point would be negative 9, negative 4. I always check my answers, whether mentally or written out, so I'll check my answer here by plugging this point into the second equation to see that that point works in this equation. We also know already that it works in this one. That's where we got our work from. But if it works also in this equation, then the two lines meet at that same point. So I plug in x equals negative 9, that's right here, minus 3 times negative 4. And the question is, does that equal out to 3? Well, this is negative 9 plus 12, because negative times a negative is a positive, is equal to 3. And that is a true statement, so we are checked. This is not the solution, it's a way to check your answer, and it's easy to check, so why not do it? All right, peeps, I've got one more type of example here. We again are going to use substitution, not only because we're told to use it, but also because in this particular problem, we have a variable on its own. Y is 2x minus 6. So negative 3x plus 2 times y is equal to negative 3. Now remember, this whole thing is y. In for y, we can plug 2x minus 6 because we're told that that is what y is equal to in the other equation. Sweet. Now, that's the new part. Remember, you should just kind of stop and say, I'm done with the new stuff. In fact, just like I've been teaching you along the way in many of my videos, I would suggest just getting to this step in 4 or 5 straight problems, getting to this step, the substitution part, and then you will be practicing all the new stuff, the heavy stuff, first. And you'll get more comfortable with it that way, rather than going through the whole process, then coming back and doing it again. All right, it'll be fresh. So now all we do is solve out this equation. So I'm going to distribute 2 to both terms. You get negative 3x plus 2 times 2x is 4x. 2 times negative 6 is negative 12. And that is equal to negative 3. We combine negative 3x and 4x is 1x. Minus 12 is equal to negative 3. And now all I have left, add 12 to both sides. Sweet. So I'm left with x is equal to positive 9. Okay, a reminder again, that's not your final answer. That is one of the two pieces. We need the y value as well. Since y is isolated in the original equation, I'm going to use it to solve for what y is. So I've got y is equal to 2 times x, which we just found to be 9, minus 6. Can't you feel the excitement? We're about to get the answer. 2 times 9 is 18. Minus 6 is 12. Beautiful. So y is equal to 12. So we have our two coordinates. And again, if your teacher wants you to write that as a point, that would be the point 9, 12. That is where these two lines will intersect. Again, to check my answer, it's worth the time. I'm going to take 9, 12 and plug it in for x and for y. Now I'm going to do this mentally this time because I showed you how to do it out, well, physically last time. Negative 3 times 9 is negative 27. 2 times 12 is 24. The negative 27 plus the 24 is negative 3. That's eventually where I'd like you to get to. For now, check it out by writing it out. And that's it, peeps. Substitution in all of its glory.